day, class. So for today's lesson, we will talk about the stars and constellation. So here in stars and constellation, we have four learning objectives, which is to demonstrate an understanding of the relationship between the visible constellation in the sky and its Earth's position along its orbits. Discuss whether or not popular beliefs and practices with regards to constellation and astrology have scientific basis. Infer the characteristics of star based on the characteristics of the sun. And lastly, the infer of that the arrangement of the stars in a group does not change. Good morning, class. So for today's lesson, we'll talk about the stars and constellations. So what is stars? Do you have any idea about stars? Just a simple definition. Okay, Anna, do you have idea? Okay, it emits light. How about you, Roger? Do you have any idea about stars? Okay, it is a massive ball of gas. Okay, you are all correct. It's because stars is a ball of gas that release energy from inside themselves. So in order to be recognized as a star, it has to have two characteristics. It should be a self-bounded by gravity, and it has to radiate energy. That's the characteristics of stars. Next, so how stars are formed? Do you even think about how stars are formed? Okay, so they are formed in space in a large clouds of gas and dust called nebulae. Atoms inside the nebula accelerated inward due to the force of gravity, and when they collide rapidly with each other, what will happen? They cause the center of the nebula to become very dense and hot. That's interesting. Causing the temperature of the protostar to rise. That's right. So the object switches to become a first is nebula. What will happen next? It becomes a true star, and it is then able to make its own heat and lights. That's how are formed. So the life of star depends on its mass. That's how our stars form. So first is the colors of stars. So the color of stars measures in its temperature. We have the red, the coolest. Very interesting, right? Yellow, an intermediate or very neutral temperature, and the blue is the hottest temperature. A star can appear bright just because it is really bright. Yeah, it's correct. Or because of its closeness to the earth. Yes, you're correct. Because stars emit colors of many different wavelengths. But the wavelength of light where the star's emission is concentrated is related to the star's temperature. Very interesting. The hotter the star, correct. The more blue it is. The cooler the star, the more red it is. That's how the color of stars determined. So the color ranges from red to blue. So the color of star indicates its surface temperature. So the coolest star is about 2,800 degrees Celsius at the surface. So this star appear red. The temperature of the hottest star is about 28,000 degrees Celsius or higher. These stars appear blue. So what is sun? The sun is only about 150 million kilometers away, and it takes only 8 meters and 20 seconds uh, for sunlight to reach our world. So its diameter is about 1.4 million kilometers, 100 times of the Earth. But yet, it is only a medium-sized star. Many other stars are much, much bigger than the Sun. So the distance. What about the distance of the stars? So the star's brightness, as seen from Earth, is its apparent brightness. So apparent brightness depends on how far a star is from the Earth. So, for example, Sirius appears bigger than Rigel, is actually, but it is actually very very small compared to Rigel. So it appears larger only because it is closer to us, to our Earth. So distance of stars. So scientists use parallax. Yes, you're correct. Parallax to determine how far away a star is from our Earth. Parallax is an apparent change in the position of an object caused by change in the position of the observer. Correct. So the closer a star to Earth, the greater is apparent change of position. Very distant stars seem not to shift position at all. So the actual brightness of the star is the astronomers consider the star's absolute brightness when comparing stars. So a star's absolute brightness is the brightness the stars would have if all stars were the same standard distance from the Earth. That's the actual brightness of the Earth, according to the astronomers. So, how about the size of the stars? We all uh, done about the colors, the temperature, and the distance. How about the size? Okay, so in stars, they are all have different sizes, just like the planets. So in stars, stars vary in size, from huge to supergiants to tiny neutron stars, just like in a dust. So astronomers group of stars into five types. We have the neutron stars, white dwarfs, medium-sized stars, which is our sun belongs to this, and the giants and the supergiants stars. So let's have first a short, very very short review on stars. But we will use it in a realistic activity. Okay, so what is the color of the filament as you dim the bulb? Do you have any idea about it? Okay, since you don't answer my question, teacher will do. So a filament radiates black body radiation with a range of wavelengths and colors. So the intensity peaks as a wavelength that depends on the temperature. So as the bulb is dimmed, the peak radiation occurs at longer wavelengths. And the color goes to what? Blue? Another. Brown? You're correct. Okay, so the colors goes from white since it is in a full power, but when we dim the bulb, it goes to brown. Correct. The color goes from white to brown. Yes, you're correct. Another. So what is the color of the filament as you turn the switch? You turn the switch at full power. Okay. Do you have any idea about it? Okay. So when you turn the switch at full power, the color of the filament is blue. Correct. Because it is due to the increasing heat. That's right, because of the increasing heat of the bulb. That's why it turns blue. Another, last, just to make a deep understanding about the sun. So what happens to the temperature of the filament as the bulb becomes brighter and brighter? Do you have an idea, class? Okay, so the brightness is proportional to the temperature of the filament. You heard it right. It is proportional to the temperature of the filament. So, as the filament heats up, the brightness increases. The increase in resistance is also happening and they all reach equilibrium because they are heated. When the heat radiates equals the heat dissipated. That's why the temperature of the filaments becomes brighter and brighter. Okay, so for your activity next week, you will have to do a measuring parallax activity and you will bring the materials needed. Okay, we have 3 masking tape, 5 pencil, 3 meter stick, and 3 metric rule. So I will just give you a hint of the analyzation or the analysis that you will be answered next week. So what happened to the pencil when the right eye was closed and the left eye was opened? At what distance from the eye did the pencil shift the greatest distance? What happened to the shift of the pencil as the distance of the pencil from the eye increased? How does the distance of an object from an observer affect parallax? Lastly, how might astronauts use parallax? That's your activity next week. Okay, so let's talk about constellation. When you look at the sky, what do you see? Do you see images of animals, objects, or people? Yes, you're right. Because constellations, in observers in ancient times also imagine group of stars that form pictures of animals, objects, and peoples. So these imaginary groups of stars are called, yes, constellations. So constellation, what are constellations? Mm-hmm. Do you have idea? Okay. Constellations are names for groups of stars that appear to form shapes in the sky. They were designed to help us remember which stars are which. There are 88 constellations that divide up in the sky. There are so many, 88. Imagine how good our God is. So, many constellations have names that can be traced back early Babylonians and Greek civilizations. So, but nearly all creators have different names for the constellations. So, for examples, Greeks called the large constellation. Do you know what is it? It is Orion, which means hunter, and is prominent in the night sky all over the world during winter. That's right. In early Filipinos, visualize the same group of stars as balik. That's interesting. A trap used in hunting wild pigs. So Christian Filipinos named the 3 stars Orion's belt, Tatlong Maria, or Tres Marias. That's right. You heard it right. Tres Marias. So, you have some common constellation that you might know? Okay, let me give you an example. So, Cassiopeia. It means the queen because it looks like a queen. Next, the Orion, the hunter, because it looks like an archer. Mm-hmm. And Ursa Major, the great bear. Ursa Minor, the little bear. Gemini, the twins. Hmm? It is another horoscope. Andromeda, the chained princess. All the constellations have different stories. So, I will ask some questions to you class. So, in what ways can constellation be useful to people? Do you have an idea? Okay. Constellations are useful to people because they help stargazers and astronomers recognize specific stars in the night sky. Correct. Constellations were also used in a proper calendar, which when it came to agricultural purposes, because people had no proper way when to sow or harvest their uh, plants, their crops. Constellations were also used for navigation and to help sailors travel across the ocean. That's right. So that's how constellation be useful to people, to us, even now. But since we are in a technological country, in a world where technology is being introduced to us, this is not uh, really popular nowadays. So, what are some beliefs and practices about constellation and astrology? Do you have an idea? Okay, since you don't answer my question, teacher is going to explain it to you. So, constellation caught also the interest of Chinese and Japanese. Some patterns of stars take after in animals such as fish, scorpion, and lions, among others. In Asian people, used constellation for religious purposes. Yes, they use it as religious purposes. And also, uh, we inherited the names of our constellation from the Greeks, and they named the constellation after mythological heroes and legends. In astrology, it is the belief that the alignment of stars and planets affects every mood, every individual's mood, personality, and environment, depending on when we was born. Because uh, this is how astrology uses constellation. Astrologers also print horoscopes in newspaper that are personalized by birth date. Yeah, it's still uh, being used nowadays. So what are so okay? So that's all for today, class. I'm hoping that you learned from this class and this lesson. So till we meet next meeting again. Thank you for listening, guys. Bye, class.